Hi everyone, I'm Divyagna, and today I'm presenting our work Sea-cret Agents. This is an abductive framework to generate regions that expose dark vessels. This is also going to be presented at AMAS in Detroit this year. Maritime vessels go dark after disabling their location, like this ship on 7th of June, typically to engage in illegal behaviors, making it hard for the analysts to detect such vessels in the whole search space. Recently, with the Russia-Ukraine oil sanction, there's been a rise in this dark activity, highlighting the need for efficient vessel detection. And machine learning approaches here are limited to short-term time horizon. And we propose an efficient method that approaches full recall of detecting these vessels while maintaining less search area as well as do long-term reasoning. For our problem, we have an input of an agent trajectory which goes dark in the middle of the grid like here. And we want to find that agent at a given time horizon. Hence, our model generates top K regions as shown by these black boxes here, where K is just a hyperparameter. And as you can see, most of the regions are indeed covering the future ground truth trajectory, as shown by the dashed line here. Our model also provides explanations for each region by noting different region types, because we learn rules based on them to model the agent behavior, and we use those rules in our framework Abduction. We provide for a formalism to reason about vessels by framing it as an abduction problem. We also provide the underlying temporally annotated logic to do so, which we use to first automatically extract rule-based behavior model pi, which captures the historical data. For instance, in this rule, the agent is first lowering its speed before changing its course of direction, and this rule has a confidence of 90% based on the historical data. We have a set of observations, which is basically the initial set of locations that the agent passed by before going dark, and for which we have many such possible regions where we want to search to find that agent, which we call a hypothesis set H. And the goal is to find an explanation that's a subset of H such that it's consistent with the behavior model as well as the initial agent locations. And we use a top K entailment query to do so, which gives us K regions like these black boxes. We want to identify greatest number of dark vessel locations while searching for the smallest possible area, because we have additional resources like drones and satellites. Hence, we record recall as a function of area. We do this for three models: our abduction model, a deep learning baseline, and a random region generator. And as you can see, for our approach, it reaches full recall at the area of 30 kilometers square, while saturating for more than half recall than the other baselines. To further investigate the area efficiency, we record recall as a function of the number of generated regions. And as you can see, for abduction, the performance is increasing monotonically, while for DL, it's converging with random baseline. So far, we looked at fixed time horizon, but now we'll look at performance with increasing time horizon. And area efficiency still holds for abduction method with a higher F1, but for DL, the F1 saturates right after the first time horizon. Our model can be instantiated with very little data. Even the use of single training trajectory gave comparable performance in F1 to the use of all of historical data in abduction, while for DL, it catastrophically failed by giving just 0.1 of F1 score. We provide further studies in the paper, including region size sensitivity and different places where the agent goes dark and different rule types. We also provide our efforts to deploy this on an operational platform. In conclusion, we provide a maritime abduction framework that generates regions approaching full vessel recall while requiring less search area. We also provide suite of experiments for data and runtime efficiency. For further work, the rules can be enhanced with a richer structure, and we can also use Neuro Symbolic techniques to improve the accuracy. Thanks for tuning in. Hope to see you at AMAS in Detroit this year.